So we're looking at the August 2019 Algebra 1 Regents, and we're looking at the multiple choice questions 13 through 24 in this video. So question 13 here is talking about a exponential function. As you can tell, it's of the form y equals a times b to the x. A little more complicated though because of this 7 up there. So a little bit trickier. So let's see what the question's asking. It wants to know which one is equivalent. And you'll notice here, again, there's a 7t and the rest all have just t. The starting value is the same here and here, but then those two are different. So we're wondering, does that actually matter? Well, I don't think it's going to be one of 3 or 4 because why would the starting value change? If it's just got a 7 in the exponent, that's not going to change the starting value, the initial value. So 3 and 4 cannot be right. So right off the bat, we know it's down to 2 options here, 1 or 2. So the question is, how do we get to that other form? How do we get to an equivalent form? Because we know that this probably is not going to change, I'm going to look at just the other part. So the 1.0005 to the 7t, and we're going to use our laws of exponents to rewrite this. So this is the same thing as 1.0005 to the 7, and then that whole thing raised to the t. Because remember that like x squared cubed, you would multiply the exponents and call that x to the 6. So if they're already being multiplied, you can unmultiply them by writing it like this, power to a power. So then you just got to figure out, well, what is this inside part? So what is this right here? So once we get that number, then we're raised to the t power and we're done. It's either this number or it's that number. And you can probably guess which one it's going to be because there's no way it could be less than 1. If you're multiplying 1.0, get to a calculator here. If you're multiplying 1.00, this is 0, 3 zeros and a 5 to the 7th, how would that be less than 1? It's multiplied by a number bigger than 1 7 times. How would it get smaller? Doesn't make any sense, which is why it's not. It's 1.0035-ish, which is why it's that choice right here, which is why it's choice 2. Again, it says approximately equivalent, so that's why they rounded it. So for number 14 here, we have f of x and g of x on the same grid. So for which value of x are they not equal? That's what this means. Where are the graphs not crossing? So every other point they're crossing. So let's see. So at -1, they're crossing here. That's the first one. They're crossing again at this x over here, which is at 2. So it can't be that one because we want the one that's not equal. And they're crossing again over here, which is -2. So it's none of those 3 because those 3 are all equal, so it's got to be choice 3. Good stuff. All right, for this box plot, a box plot is always made from the 5-number summary, which is the min, quartile 1, median, quartile 3, and maximum. And remember, you can always get to those if you have data, not for this problem, but if you have particular data and you're putting numbers into a spreadsheet like this, just making up numbers here. If you go to menu, statistics, stat calc, 1 variable statistics, you can get the 5-number summary for you right there. So there's your min, quartile 1, median, quartile 3, max. So if you ever have to make your own box plot, remember you can use that tool to do all the hard work for you. So the range is always the maximum minus the minimum, a simple subtraction here. So 8 minus 1 is just 7. What a great question. Love that one. Okay, not equivalent. We're looking at this one here. So we're looking at factoring this because these are all in factored form. I also see that this 2 is out front, which shows me that's probably factored completely. So right off the bat, I can tell that these 2 are equivalent because 2x plus 6 is equal to 2 times x plus 3. So if we're asking which one's not equivalent, then it's probably going to be not one of those 2 because those are equivalent. So meaning if this one was not equivalent, so would that one because they're both the same. So because they're both the same, we know that they're both not our answer, if that makes sense. Similarly, if you look at choice 1, 2x plus 4 is the same thing as 2 times x plus 2, and there's an x plus 3 on it too. And if you look at this, that's the same thing too. So if all 3 of these things match, then they can't be the wrong one. This one's got to be the wrong one because if you multiply that out, you could double check. That would be 2x squared plus 8x plus 3x plus 12, which is 2x squared plus 11x plus 12. not 10x. So that's why that one's wrong. Different ways to approach that one, but hopefully that makes sense. All right, looking at 17 here. So we got r of x and q of x. What will be the function with the smallest minimum value? So minimum value we see here for r of x is at negative 16. Let's add some color to that, make it look pretty. Boom. So smallest value is negative 16, and it happens at negative 2. So there's the min. So if we see one, like, for example, can't be choice 4 because the value is not negative 2. The smallest value is negative 16. And then let's go to q of x. For that one, I'm just going to graph it and look at what the graph looks like because, that's probably the fastest way to do it. You could use putting the square, but, why? Because you could find the vertex that way, and that would tell you the smallest value if this actually opens upwards, so we know that the vertex would be the minimum because this is a positive leading coefficient. So that means it opens upward. And then if we go to our table, Control T, I'm going to go backwards here. My table at -1, -9. So the smallest value of that is always the y value. So -9, that is true. That is the minimum for q of x, not 2. But that's not smaller than negative 16. Duh. So there's choice 3 as our answer for 17. Number 18 here. We're looking at a graph. Which interval did the child constantly move closer to home? So constantly is key. So it can't be anything that's not a line. So it can't be the section between 2 and 3. And moving closer to home. So this is the distance. It says here, distance from home. So getting closer to home means that we're decreasing. So negative slope. So we're looking for a decrease, a negative slope here, which happens right off the beginning here, decreasing right there. So getting closer to home is in between 0 and 2 seconds. This would be a positive slope and a 0 slope, so those can't work. These sequence questions always look really tricky because of the way that the wording or just the recursion here. This is a recursive formula. So it says A2. So A2 is based on A1. So A2, that would mean that n equals 2. So A2 would equal 3 plus 2 times A2 minus 1 squared. So A2 would equal 3 plus 2 times A1 squared. And we know A1 is just 6 because it says A1 is 6. So it's 3 plus 2 times 6 squared, which is 3 plus 2 times 36, which is 3 plus 72, which is 75. Choice 1. Let me scroll. There we go. Number 20. So the length of the patio is 7 feet more than its width. So the length is the width plus 7. So the area is just length times width. So it's W plus 7 times W. And if you multiply that W in, it'd be W squared plus 7W. Done. Dolphin, let's see. Domain for this, we're talking about the domain is always the inputs. So what values of inputs would make sense? The distance is the y, and x is time. So what makes sense for time? We don't want real numbers because we're not going to have negative time. We're not going to be looking at a graph of a dolphin, back in time. So that's not going to make any sense. Integers also would be negatives, and that wouldn't make any sense. And you also want decimals. We also want like 2.5 seconds because the dolphin is not teleporting every second to make this jump out of the air. So we would assume that the jump is continuous, time is continuous. So decimals make sense, which is why we want the real numbers. We don't want integers because that would be no decimals. For this one here, we're looking to see which solution or system has the same solution. So if we look for some patterns first, x plus y equals 5. Those match in those 3, so that's kind of nice. So hopefully it's one of those 3. And then we can say, okay, well, can we get, let's see, is there a shorter way to do this? I don't really see one. We could just go ahead and solve this. Why don't we do that? Why don't we go ahead and solve this over here? You could type in your calculator too. Don't forget there is the tool. I'm just going to show that because, it's multiple choice. We don't have to show work. So algebra, solve a system. I did the wrong one. Let's try again. Algebra, choice 3. Solve a system, choice 2. 2 equations, x minus 4y. To be honest here, this is probably going to take longer doing on the calculator, then I could have just done without the calculator, but I like to show tools that you have access to. X plus y equals 5. And there we go, 2, 3. But again, we could have solved it pretty quickly if I just did this one times -1. It would be x minus 4y equals -10, -1x minus 1y equals -5. And here's why you actually might want to do it like this, because those go away. You get -5y equals -15. So then you get y equals 3. And I thought that would have gotten us there. So there's right here, you can see how that's not going to work. -5y equals -15, so it can't be choice 2, which is somewhat helpful. But we still need to find x, so x plus y is 5, so x has to be 2. And then I would probably just test them at this point. Go to the first one. We know it works in the bottom, because that one's the same as this one over here. So is 5 times x 10? Is 5 times 2 10? Yes. Our x is 2. 5 times 2 is 10. So pretty easy to check that. Lucked out that it was the first one we had to check. If you check the other ones, you'll see they don't work. For this one, which interval represents the range? So range, we could just look at the graph. That's what I would always do. If you don't have a picture, I would make a picture. So make the graph here. Be careful to type the right letters. That's always important. 2x squared minus 2x minus 4. So our range, let's go to our table. And I see some decimals here, which is interesting. That implies that we're probably going to have a decimal to look at here for the vertex. I'm going to go to table settings here, edit table settings, and I'm going to do a table step of 0.5. That way I'll get to the decimals. And we'll see the vertex is right there at negative, or 0.5, negative 4.5. So the range is always the smallest y value to the biggest y value. So there's the smallest, there's the min, and it increases forever, so it's got to be choice 4. Geometric sequence, first term is 5, third term is 245. So 5 is the first term, don't know the second term, third term is 245. So something is happening here where we're multiplying by something here, and that same something over here. So what we want to do is think about, okay, well, what would 245 divided by 5 be? You know, that would be 2 jumps. So if I go to a calculator and just divide that quick, that's 49. So this big jump is times 49. So you want to think about, okay, well, what 2 little jumps are the same thing as times 49? So it's 2 jumps getting to 49. So we're taking a square root of 49. If it was 3 jumps, it'd be a cubed root, 4 jumps, fourth root, etc. You're trying to figure out what number times itself is 49. And that's 7. Because times 7 is the same effect as times 49. So our common ratio has to be 7. That's it for these multiple choice questions 13 through 24 of the August 2019 Regents for Algebra 1.